Good morning, children. I welcome you all to the chemistry class. We are continuing with the chapter Periodic Table. In the last class, we were discussing about different types of members which are included in the periodic table. That is, representative elements, transition elements, lanthanides and actinides. As we come to the last part of the chapter, we are discussing some of the characteristics or some of the factors on which the elements are depending. So in this chapter, we are dealing with 4 of them: atomic size, ionization energy, metallic and non-metallic character, and electronegativity. So first we are going to see about the atomic size. Okay, so I am going to write some elements here. Okay, lithium, sodium and potassium. As you all know, atomic number of lithium is 3, sodium is 11 and potassium is 90. I am writing the electronic configuration here: 2, 1, 2, 8, 1, 2, 8, 8, 1. Okay, you know about this. Now I am going to draw the electronic configuration, the Bohr atom model of these elements. Okay, so first I am drawing lithium. A nucleus first, 2 electrons, 1 electron. This is lithium. Okay. Next is sodium. 1, 2, 3. Okay. 2 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. Then 1 more electron. Okay, this is sodium. Now I am going to draw about potassium. 1. How many number of shells? 1, 2, 3, 4. So 1, 2, 3 and 4. So here 2 electron, 3, 4, 5, 6, 7, 8. Again 1, 2, 3, 4, 5, 6, 7, 8 and then 1. So this is potassium. Okay. So as you look at the Bohr atom model of these 3 elements, that is lithium, sodium and potassium, you can find something. What is it? The size of the atom as you move down the group. So these are elements down the group, isn't it? Top to bottom. Top to bottom. Okay. So as we move from top to bottom down the group, you can see that as we move down the group, as we come from lithium, then to sodium and then to potassium, you can find that the size of the atom increases, isn't it? The size of the atom increases. The number of shells is keeping on increasing. Here for lithium it was only 2 shells and for sodium it was 3. For potassium it is 4. Now when we go to potassium, rubidium, cesium etc., you can find that the number of shells will be keeping on increasing. Why? Because the nuclear charge is increasing. Because the number of protons is keeping on increasing. Okay, the number of protons increases. Atomic number is increasing. Atomic size is increasing. Atomic number is greater. As we move down the group, you can see atomic number is increasing. See here 3, then 11, then 19. And number of shells is also increasing. See here it is only 2 shells, then here 3, then 4. So as you look at the Bohr atom model of these elements, you can find the number of shells keeps on increasing, isn't it? So the atomic size also increases. So as we move from top to bottom down the group, the atomic size of elements increases. Now I'm going to write elements left to right across the period. You know what are groups and what are periods. Vertical columns are called groups and horizontally when you write you can call it as a period, and when we go down vertically you know they are groups. So we have 18 groups and 7 periods. Don't forget about that. Now I am going to write some elements across the period. Lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, so these are the elements which I have written across the period. Left to right. Okay, left to right across the period. Left to right across the period. You can check with the periodic table. Atomic number: lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9 and neon 10. Now I am going to draw the Bohr atom model of these elements. Okay, first lithium. Okay, then beryllium. So here is 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 2 7 and 2 8. Okay, now beryllium. Then boron. Then carbon. Then nitrogen. Now oxygen. Then fluorine and neon. Okay. Now I am going to represent the number of electrons here. Lithium 2 and 1. Here also. Two and 1. Here 2, 2. Here 2, 3. Then here 2, 1, 2, 3, 4. Then here 5, 1, 2, 3, 4, 5. Here 2, 1, 2, 3, 4, 5, 6. Here 2 electrons. 1, 2, 3, 4, 5, 6, 7. Then neon. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, here it is 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7 and 2, 8. So here I have written the electronic configuration, the Bohr atom model of these elements. So as you go through the atomic number, you can see that when we move from left to right across the period, you can see that the atomic number is increasing. Like 3, 4, 5, 6, 7, 8, 9, 10. Isn't it? Atomic number is increasing. That is, number of protons is keeping on increasing. Now when I am writing the electronic configuration also, you can see 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7 and 2, 8. But when you draw the electronic Bohr atom model, you can find that the number of shells remains the same. See, only 2 shells are there. Only 2 shells are there. As we move from left to right across the period, you can find that only 2 shells are there. The number of shells is not increasing, but the number of electrons is keeping on adding to the same shell. Okay, so here the atomic size remains the same. When we move from left to right across the period, you can see that the atomic size is number of electrons is keeping on increasing, but the atomic size decreases. Why does atomic size decrease? So you can see that when you analyze each element, the Bohr atom model of each element, you can find that the electrons is being added on to the last shell. Here in the last shell it was 1 electron. In the second shell there were 2 electrons. Third one, boron, there were 3 electrons. In carbon, 4 electrons. Then nitrogen, there are 5 electrons. Then oxygen, 6. Then fluorine, 7. And neon, 8. So in the outermost shell, the number of electrons is keeping on increasing. So you all know that a nucleus is there. In the middle part, the central part of the atom, you have nucleus. This nucleus will be attracting the electrons. The nucleus is positive charge. Electrons are negative charge. So we all know that the positive charge will always be attracting the negative charged particles. So what happens? The positively charged particles, the positively charged nucleus is attracting the negatively charged electrons. So as we move from left to right across the period, നമ്മൾ ലെഫ്റ്റ് നിന്ന് റൈറ്റിലേക്ക് പോകുന്ന സമയത്ത് ഓരോ ഷെല്ലിലും ഓരോ ഇലക്ട്രോൺ വെച്ച് കൂടി പോയിക്കൊണ്ടിരിക്കുകയാണ്. അപ്പോൾ എന്ത് സംഭവിക്കും? നെഗറ്റീവ് ചാർജുള്ള ഈ ഇലക്ട്രോൺസിനെ ഈ നടുക്കുള്ള ന്യൂക്ലിയസ് ഉള്ളിലേക്ക് വലിച്ചുകൊണ്ടേയിരിക്കും. നമ്പർ ഓഫ് ഇലക്ട്രോൺസ് കൂടുന്നതിനനുസരിച്ച് ആ അട്രാക്റ്റീവ് ഫോഴ്സ് കൂടിക്കൊണ്ടിരിക്കും. അപ്പോൾ ന്യൂക്ലിയസ് അതിന്റെ ഉള്ളിലേക്കാണ് വലിക്കുന്നത്, ഉള്ളിലേക്ക് വലിക്കും. അപ്പോൾ നമ്പർ ഓഫ് ഇലക്ട്രോൺസ് കൂടുന്നതിനനുസരിച്ച് ഈ അട്രാക്റ്റീവ് പുള്ള്, ഈ ഫോഴ്സ് ഓഫ് അട്രാക്ഷൻ കൂടിക്കൊണ്ടിരിക്കും. അപ്പോൾ നമ്മൾ ലെഫ്റ്റ് നിന്ന് റൈറ്റിലേക്ക് പോകുമ്പോൾ എന്ത് ചെയ്യും? അറ്റോമിക് സൈസ് ഡിക്രീസ് ചെയ്യാണ്. കാരണം ഇലക്ട്രോൺസ് കൂടുന്നു. ഇലക്ട്രോൺസ് കൂടുന്നതിനനുസരിച്ച് നടുക്കുള്ള പോസിറ്റീവ് ചാർജ് ന്യൂക്ലിയസ് എന്ത് ചെയ്യും? ഇലക്ട്രോൺസിനെ ഉള്ളിലേക്ക് പുള്ള് ചെയ്യും. അപ്പോൾ അറ്റോമിക് സൈസസ് decreasing. So as we move from left to right across the period, atomic size decreases. Okay. Now the next one we are going to study is about ionization energy. Now what do you mean by ionization energy? Okay. Ionization energy means, see, sodium. Okay. Sodium is having atomic number 11. This 2, 8 and 1. Okay, 2, 8 and 1. So we all know that if sodium is losing 1 electron, it becomes stable state. It becomes Na plus, that is sodium ion. It becomes sodium ion, isn't it? It becomes sodium ion. So when sodium loses 1 electron, it becomes sodium ion. So the tendency of an atom, okay, the tendency of an atom to lose the most loosely bound electron, or the energy needed to remove the most loosely bound electron from an isolated gaseous atom, that is known as ionization energy. Okay, the energy required to remove the loosely bound electron from an isolated gaseous atom, that is known as ionization energy. So here you can see that there is only 1 electron. So what energy we are using to remove that electron from the outermost shell? What energy we are using to remove the electron, the loosely bound electron from the outermost shell, that is known as ionization energy. Now, we are going to analyze how the ionization energy, the trend of ionization energy, down top to bottom, the group, and left to right across the page. So whatever characteristics we are studying, we have to analyze in both the cases. That is top to bottom, down the group, and left to right across the period. So this this ionization energy depends on two factors, that is nuclear charge and size of the atom or atomic size. Okay, anyway, size of the atom. So, ionization energy is depending on two factors, that is nuclear charge. Nuclear charge means number of protons. Size of the atom, that is the atomic size. Now, here lithium, sodium, potassium, rubidium, cesium and francium. Okay. So, I told you when we were discussing about the atomic size, I told you when you deal with the atomic numbers of these elements. Okay, atomic number of these elements, I told you the atomic number keeps on increasing. Okay, the atomic size keeps on increasing. Okay, the atomic number keeps on increasing. Now, as we move from top to bottom down the group, the number of protons increases. That is why atomic number increases. Number of protons increases. Atomic size increases. Atomic size increases. So, as the atomic size increases, okay, as the atomic size increases, the attraction between the nucleus and the loosely bounded electron in the outermost shell will be, the distance between them is very large, very much. There is a lot more gap between nucleus and the electron which is present in the outermost shell. Why? Because the atomic size is increasing. Atomic size is more. Okay, so I will show you an example. See, first I am drawing lithium here. Okay, lithium. Here only 2 and 1. Now if I am drawing potassium, 1, 2 and 3, isn't it? So 1, 2, 3, 4, 5, 6, 7 and 8, and then only one electron. See, the distance between this outermost electron and the nucleus, see the distance, it is very near, isn't it? The first element, lithium is the first element. So the distance between the outermost electron and the nucleus is not that much, no, the gap is not much, it is very near. So here ionization energy will be more in the first element because attraction is more. Nucleus and the electron is very near, so the electrostatic force of attraction will be more. So more energy should be needed to remove this electron. More energy, because it is very difficult to break that force of attraction between the nucleus and the electron and remove this one. So ionization energy will be more. Now you are coming to this one. See, the distance between the outermost electron and the nucleus is more here. Is it? The distance between the nucleus and the outermost shell is more. So the attractive force will also be less. As the distance increases, the force of attraction will be less. The force of attraction between the nucleus and the outermost electron will be less. So less energy will be required to remove this outermost electron. So we can understand that as we move from top to bottom down the group, what happens? The ionization energy decreases because size of the atom increases. As the size keeps on increasing, what happens? The distance between the outermost electron and the nucleus, which is at the center, keeps on increasing. The distance becomes more and more and more. So the force of attraction will be less. The force of attraction between the nucleus and the outermost electron will be less. So, little energy will be required to remove that electron. So, from top to bottom, from top to bottom down the group, the ionization energy is decreasing. Okay. Now, next one, across the period, lithium, carbon, nitrogen, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So, now lithium, okay, in beryllium, boron, nitrogen, oxygen, fluorine, neon. So when I was discussing about the number of electrons here, I told you that the number of shells remains the same. Number of electrons is keeping on increasing, but number of shells remains the same. But electron is keeping on increasing. So here 1 electron, here 2, here 3, here 4, here 5, then here 6, here 7, and here 8. Okay. So here left to right across the period, we can see that the number of shells remains the same, but the number of negatively charged electrons keeps on increasing. So what I told you about the atomic size, as we move from left to right across the period, left to right across the period, atomic size decreases. Why? Why atomic size decreases? Because the negatively charged electrons are there. The negatively charged electrons are keeping on increasing. From one element to the next element, the number of electrons, negatively charged electron is increasing, and the negatively charged electrons are being pulled by the positive charged nucleus. So, as more and more electrons are being added on, the force of attraction will be more. So, do you think that if this nucleus is pulling these electrons towards itself, more and more energy will be required to remove one electron from this? Because the force of attraction, the electrostatic force of attraction between the nucleus and the loosely bound electron. Here see neon, there are 8 electrons. They are already stable. So these 8 electrons are pulled by the positively charged nucleus because distance is also less. So what happens? The more energy will be required to remove at least one electron from the outermost shell. So as we move from left to right across the period, ionization energy increases. From top to bottom, ionization energy decreases, and from left to right across the period, ionization energy increases. Now we are going to discuss about another property in the periodic table, that is metallic and non-metallic character. So as we go from top to bottom down the group, you can find that lithium, sodium, potassium, rubidium, they are all metals, isn't it? Now next one is beryllium, magnesium, calcium, strontium, radium, they are also metals. So as we move from top to bottom down the group, the metallic character is increasing. As we go from lithium to potassium, sodium, potassium, rubidium, etc., the metallic character is increasing because the size of the atom increases, ionization energy is less. But when we go from left to right across the period, that is when we go from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, you can easily say that lithium is a metal, beryllium, boron are metals. Whereas when we go from left to right across the period, what happens? The metallic character decreases and the non-metallic character increases. Next one is electronegativity. What is electronegativity? You have studied this in the previous chapter, electronegativity. The capacity of the element to attract the bonded electrons towards itself is known as electronegativity. Now, in this electronegativity also, you can say that as we move from top to bottom down the group, electronegativity is decreasing. Okay, electronegativity is decreasing. So, francium, there is, if you tell about the first group, there is lithium, sodium, potassium, rubidium, cesium and francium. As we move down the group, what happens? The electronegativity is less. So, francium is the most less electronegative element. Now, what happens when we move from left to right across a period? When we move from left to right across the period, the electronegativity keeps on increasing. So, in the whole of the periodic table, you can say that fluorine is the most electronegative element. So, in this chapter, we have discussed about the history of the periodic table. What are the different elements, how groups and periods are classified? What are groups and what are periods? And what are the properties which we have to consider while studying the periodic table? So first we studied about atomic size. In atomic size, as we move from top to bottom down the group, the atomic size keeps on increasing because atomic number increases, the number of shells also increases. But when we go from left to right across the period, atomic size decreases. Why? Because the number of shells are not increasing, only the electrons are keeping on increasing. So the force of attraction between the positive charged nucleus and the negatively charged electron is more. So the attractive pull will be, so atomic size decreases. Then we studied about ionization energy. Ionization energy depends on two factors, that is nuclear charge and size of the atom. As we move from top to bottom, since the size of the atom is increasing, ionization energy will be less. But when we go from left to right across the period, since the size of the atom is less, as the force of attraction is more energy is required to remove the electron. So ionization energy is increasing. Then we studied about metallic character, non-metallic character and electronegativity. As we move from top to bottom down the group, metallic character increases, whereas when we go from left to right across the period, the metallic character first decreases and then non-metallic character decreases. And last, electronegativity. Top to bottom, electronegativity is decreasing, and across the period, electronegativity is increasing. So that's all for this chapter, periodic table. We have finished the chapter periodic table.